Hi, okay guys, this is for those of you who find it a little bit difficult to understand the parallelogram method versus the tip to tail method, right? Okay, so in the parallelogram method, you know that you just need to draw out your forces over here, right? So you draw out your two forces over there and then you draw the parallelogram, okay, and then boom, there you go, that's your resultant force, okay? Now for the tip to tail method, what you're actually trying to do is you are just trying to shift one of the forces such that the tip of one of the forces touches the tail of the other force, like that. And then after that, since this is the start point, right, of your object, and this will be the end point, right, the resultant force is drawn from the start point to the end point, like that. Okay, so when you compare the two resultant force, either you use the parallelogram method or you use the tip to tail method, you find that actually the resultant force will be the same. How do we know? Okay, we can actually compare that later, right? Okay, some of you are asking, okay, can you also slide the force at the bottom upwards like that, so that the tip of this arrow touches the tail of this arrow? The answer is can, right? And then how do you draw the resultant force? You draw the resultant force such that from the start point to the end point, like that, right? So the resultant force is drawn like that also, right? So you see that either way you slide the forces, you will get the resultant force to all be in the same direction, all with the same magnitude, right? So if I compare parallelogram, the first tip to tail, second tip to tail, all the resultant force is the same, right? So what's the difference between parallelogram and tip to tail method again? Parallelogram is after you draw out the two forces like that. After you draw this, you draw the parallelogram and then you draw the resultant force. For tip to tail method, you must slide one of the forces, okay? So you slide one of the forces such that the tip of the tail touch the the tip of the force touch the tail of the arrow over here. Then you draw your resultant force like that. Okay. So basically for tip to tail and parallelogram method, okay, that is the main difference. Okay, how to draw it? Okay, the method is all the same, right? You always start with a scale, right? Scale, okay, 1 centimeter represents how many Newton? Okay, so sometimes, or most of the time, not say most of the time lah, okay, sometimes we can use 1 Newton, okay, then sometimes we will use other values as well, right? Okay, and then from there you can draw out your object like that. Okay, draw out your object, okay, and then you can draw out your first force. Okay, let's say for example, the question tells you that it is a okay, hold on. Okay, sorry. Let's say for example the question asks you to find the resultant force using the tip to tail method. Okay, using the tip to tail method. Okay, so what you're gonna do is you have the 5 Newton force here, you have the 3 Newton force there, right? Okay, so you represent the object with a dot first. Okay, then after that, okay, you can draw out your 5 Newton force, right? So you use a suitable scale. Okay, maybe you choose 1 cm represent 1 Newton, right? So this one will be 5 centimeters, right? So this one will be 5 centimeters will be equals to 5 Newton. Okay, so you can draw that out first. Okay, now you need to draw this part over here, right? You need to draw this part over here because the tip of this arrow must touch the tail, right? So in order to draw that part, this 3 Newton force, right? This 3 Newton force, you need to slide it up over there, right? So you need to slide it up over there. So once you slide it up over there, right? What will happen is that this angle, you must find out what the angle is, right? You must find out what the angle is. So this angle, how do you find that angle? You find the angle by taking 180 degrees minus 60 degrees equals to 120 degrees, right? So this angle is 120 degrees. How we know it's 120 degrees? Because this one and this one, they are parallel because you are just sliding the 3 Newton force up, right? Okay, so this is 120 degrees. Okay, then you draw out. Okay, there you draw out 3 cm equals to 3 Newton, right? So you get this, right? Then after that, you can draw out your resultant force, right? Okay, so this is method number 1. Okay, you can do it like that. Okay, some of you will say that, sir, why must go and calculate until 120 degrees like that? No need ma, because if you extend this line, okay, if you extend this line, you realize that this one and this one, they are parallel, right? So if this is 60 degrees, then this one is also 60 degrees, right? You call this corresponding angles in math, right? Okay, you call this corresponding angles. So you extend the line out like that. Okay, extend the line out like that. You measure 60 degrees, right? Okay, you measure 60 degrees and then you draw out your line like that. So it becomes 3 cm equals to 3 Newton. And then you draw out the resultant force also. Okay, so I hope that helps. Okay, if it doesn't, just drop me a text again. Okay, I'll try to see what else I can do, okay, to help to explain this better. Right, Ken? Take care.